right, Algebra 2, or Advanced Algebra, whatever you want to call it. I'm going to be doing Lesson 4, Identifying Functions and Function Notation. Let's jump right in. I'm going to go over some things and then I'll do the lesson practice. So first things first what is a function? So a function, you have your input and your output, but what defines a function is each input has exactly one unique output. Okay, so for example, here's an example of a function, and it can be shown in a table, it can be shown in circles. So if I have input's usually always on the left, so here's my input, -5, -2, 1, 3. So I can assume if it's on the left, that's my input. Here's my output, 2, 4, 0. Here's my output. And let's say when I plug -5 into the function, it gives me 2. -2 gives me 4. Both 1 and 3 gives me 0. Now this kind of confuses people. It's okay for this input to have 0 and this input to have even these, because these are different. If I plug in 1, I get 0. If I plug in 3, I get 0. That's okay. It's okay. These are different and they're getting exactly one answer. So this would be a function. What would make it not a function? So I'm going to write that on the left. Not a function. So I'm going to kind of almost have the exact same input. -5, -2, 1, 3. And I'm going to do -5 again to show you the difference. And then here's my output. So let's say I have 2, 4, 0, 3. So again, I'm going to match them up just the same as the last one. Now, this is not a function. Not because of these guys. This has a 0 as an output. This has 0 as an output. It's because -5, when I plugged it in at 8 a.m., gave me 2. Later that day, I plugged in -5 and got 3. So the value of -5 has 2 different outputs, and that's what makes this not a function. So what makes this not a function is this guy right here. -5 has 2 different outputs. So this is not a function. Again, if it's on the left, this is your input, and this is your output. So that is one way to tell whether something is a function by your input and output. Every X should have only one output, no matter when. Think of this as a machine. No matter when I plug in -5, I should always get the same output. Okay? Next thing this section covers is domain and range. Domain is your input values. Using algebra, these are always my X values. We also call my input independent. Range is your output values, or most likely your Y values. And it is dependent on your function, like your rule. Like when I plug in X, do I add 2? My Y values are dependent on what we do to X. So an example, if I use the table above, which was -5, -2, not a table, but if I use the bubbles above, and I've got 5, boom, 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 the domain, I would say, is -5 to my range is 2, 4, and 0. You don't need to list 0 twice. Okay? That should be review. Another way to test for a function would be something, and it's review, you guys probably remember this, the vertical line test. Really easy test. Okay, if I draw a vertical line through a graph, it can only intercept once. Okay, so for example, I'm going to draw 3 graphs. 1, 2, 3. If I was to draw a vertical line, it only intercepts this one time. So, yes, it is a function. Okay? If I was to draw a vertical line through here, notice it hits it twice. So, no, not a function. And this last one, even though it's a weird shape, it only intercepts it one time. So yes, it is a function. Okay? So that is all the review on whether I can tell something is a function and talking about domain and range. The last part of lesson 4 covers function notation. And we need to be familiar with it and actually comfortable with it so you guys are not freaked out later by it. So function notation gives a function a name. For example, here are my 2 functions. Y equals x plus 2, y equals x minus 5. Both are named by y. So right now, these 2 different functions have the same name. So if I said, hey, plug 4 into the function of y, you'd be like, well, which one? So function notation gives each one a unique name. So instead, function notation would look like this. F of x, it's just telling you your input. So this is f, that's the name, the function of f. This is my inputs are x. F of x equals x plus 2. So this is my name, the function of f. Okay, and then let's say I'm going to name this one the function of g, but I always put my input in parentheses. So the function of g equals x minus 5. So I would say that this is the function of g. Okay? Know that this is just, it's telling you that x is your input. Okay? It's not multiply. Function of f, or you could also call this f of x on how you would say it. So let's practice using this. So if I said, I think we're on example, I don't think I've done examples. So for example, evaluate the function of g when x equals negative 8. Okay? So that would mean that I would take, I just don't know why I labeled that a. So I would say g at negative 8, that's the name, this is my input, okay, equals x minus 5. Now instead of writing x, I'm going to put my input in parentheses. So that equals negative 8 minus 5 is negative 13. So I would say the function of g, when I plugged in negative 8, equals negative 13. Okay, so that is my output. Input, output, slash answer. Okay, now what if I now ask you evaluate the function of f of x equals 2x minus 6 when x equals, I don't know, negative 4. Hope you guys can see all of that. So I am using the function, I'm using this function, but they're telling me to plug in negative 4. So I'm going to put a negative 4 where x is. So notice input, put where x was. Okay? So that is negative 8 minus 6, which equals negative 14. All right, so that's examples of everything we're going to cover today. Now I'm going to do the lesson practice with you. So lesson practice is on page 24. And we're going to jump right in. So part A, I'd asked us to say whether it is a function and then identify domain and range. So part A is not a function because x equals 3 has 2 different y values. Okay, so I wrote that all out. My domain is, I'm going to list all my values, so 3, 6, and 2. And my range is 9, 7, 5, and 4. Part B. Part B is a function because each letter has its own output. So my domain is M and N, and my range is just P. All right, now in C, D, and E, we're doing the vertical line test. So C, if I was to draw a vertical line, the answer would be yes. It only crosses it once. Again, you guys pause. You can pause the video right here, draw the vertical line test through D and E, and then we'll determine whether, and then you can check my answers. So D, if I drew a vertical line test, it would not pass. And then E, if I drew a vertical line through that graph, yes, it is a function. All right, moving on to F. I hope you can see that. So F states that I have, and I think yours is different, but it gives us the function of v of x equals 9x plus 3x squared, and it said to find the value of v at 2. So I'm just writing v at 2. That means I'm using the function of v, and I'm inputting or plugging in 2. And then I'm going to write 2 wherever there is an x. So I'm plugging 2 in here and here, and I'm going to simplify, right? This part here, 9 times 2 is 18, plus 3 times 4. I have to do exponents first. And so now I have 18 plus 12. If I add those together, I get 30. All right, G. G gives me a value of points. It says that one ticket costs $25. Okay, so one ticket costs $25. And it asks us to then find, there's a one-day special, and if you buy one ticket at regular price, each additional ticket costs $20. Okay, and it says find the total cost if I buy 2 tickets, 3 tickets, 4 tickets. Okay, so X represents tickets, Y is cost. So this would be 45, 20 plus 25. This would be 65, and this would be 85. Because the cost after one ticket is only $20. If I buy another one, it's 45. Another one, 65. Another one, 85. Then it asks if this is a function. So yes, it is a function. Because every ticket price, every number of tickets that you purchase is a different price. So yes, it is a function. My domain so far is 1, 2, 3, 4, and my range is 25, 45, 65, 85. They could also be written slightly different. You could also write X is greater than or equal to 1, and X is, but we'll just leave it at that. H, very similar. They tell us if I buy one t-shirt, it costs $15.50. They're having a buy one, get one free sale. So if you buy one, you get one free. Find the total cost if you buy 2, 3, 4, 5, and 6 t-shirts. So I know if I buy one t-shirt, it's $15.50. They have a buy one, get one free. So that means that if I buy 2 t-shirts, I still pay $15.50, right? Because I bought one, I get the second one free. If I buy 3 t-shirts, that's $15.50 plus $15.50 plus 0. 1 is free. Okay, so that means that this here would be $15.50 plus $15.50 is 31. If I buy 4 t-shirts, I'm actually only paying for the cost of 2 of them, right? Because then I would get another free one. So this is still 31. If I buy 5 tickets, that's 31 plus $15.50. So that would be, I believe, 46.5. And 6 would still be the same. I would just get a free t-shirt. And so here are my ordered pairs. Is this a function? No. It's not a function. Actually, sorry. It is a function because I can have the same y value as long as my x values are different. And I believe it also asks for domain. Domain would be 1, 2, 3, 4, 5, 6, and range, this would be 15, 50, 31, and 46.5. All right, so homework for this section, the numbers you're going to skip I have already put into Canvas, but these are the notes, and we are done.